Okay, so let's me start with the coding part here. We have this sensor simulation, which is basically some people did in Python and we did it in Java, because for me, as I'm a Java developer, it was easy to write in Java than Python. So we used Spring Boot framework. So you can see this is a Spring Java Spring framework application, and also it's a Maven application. So in Python we use requirements.txt file. In Java we have two options. One is Gradle. You guys, if developed Android, you will see there is a Gradle, but there is another packaging which is Maven, that has this XML type of listing of dependencies. So here we can see the dependency of Spring Boot state starter, and other important dependencies that we have here is this like the JSON processor, and also we have the dependency of MQTT. Let me find out where is the dependency. Okay, so Spring integration MQTT. So Spring framework has lots of integration. So they also provide MQTT integration. So the benefit of is, so you can see literally here we have a simulator class. So there we can just say auto weird, and we can just add the dependency of the MQTT with just this property. Nothing needs to be done other than this. So the configuration is coming from this file. I have another file, MQTT config here. It basically takes the server URL. So you can see this is a value annotation, and it's basically MQTT server URI. So where this coming from? This can come from two places. One is your environment variable. Another place is this application properties. It's just a key value properties file. So here you can see we have this MQTT server URI, and here is our URL, and in the config we just bind the other things: username, password, and MQTT requires a topic. So with this topic we can just create a like wow factor. These are some boilerplate code, you will find documentation, just copy paste it, and that's how MQTT works. Now in the simulator we are defining some of our own property like humidity, light intensity, temperature, soil moisture, livestock. These things are enabled or not. And then we have number of farms and number of areas to cover. So once we start simulating, we just iterate over the farms and iterate over the areas, and then we send the like temperature, soil moisture, humidity, all these readings, and also the livestock readings. So the reason of separating the functions, because these are simple, the sensor readings, right? We just if something is enabled, we just generate a random value between some numbers and add some farm ID and area ID tag. But if it's a livestock, there are two different kind of livestock, so we need to put a tag, like we can add a name of the animals and their heart rate and then add some additional tag, animal ID, animal's name, these type of things. So then we are sending the data to the MQTT server. So as the data is being sent in the MQTT, now the MQTT is a broker, so someone needs to consume that data that we are producing from our application. So now if I start the application, so it's running and it's sending the data. Now if we go to NodeRED, here we have this MQTT. So you can see this MQTT in and MQTT out. So MQTT out means producing and in means consuming. We have this MQTT in here, and here we have provided the IP address of MQTT and port, and also I think we need to put the topic name somewhere. Let me check. Okay, we put the topic name smart sensors. So if you look at our code here in the MQTT, so we have this property MQTT server topic. So that is coming from our application properties. So we have defined the topic here as smart sensors. So that's where our data is going. Now we have the data being received by NodeRED, and now we are like connecting a InfluxDB with it. So that basically means after consuming the data, they are coming as message.payload, and those data is getting inserted into InfluxDB. So the node I am using for this is InfluxDB out. You can see, tell by the icons. So it's basically writing the every data to InfluxDB. So NodeRED is processing the data. Okay, so that's the InfluxDB part. Like if we now log into InfluxDB, and we can see the sensor data here. All the data are coming: humidity, light intensity, livestock, soil moisture, temperature. So if we put last, you can see all the values are coming here. Okay, so next part is now sending the alerts. So for sending the alerts, the InfluxDB data that we are writing, we have defined a trigger here which reads every 5 seconds from InfluxDB, and every 5 seconds it executes a query in InfluxDB. So the query is basically this, like it reads the measurement of sensor data, and like then the window size is -1. That means last second, but you can increase it so you can get more data point, but we don't need so many data points. So the smallest one as possible I will put here. What happened? Is it still being recorded? Yes. Okay, so we have this query, and the query is being executed in InfluxDB, and then InfluxDB is giving us the output here as another message.payload, and in compare threshold, we are like comparing the threshold. So I will tell what is this in a moment. That then let's say this is just comparing the data with some kind of threshold that we are getting here, and then after
based on which the alert is going to be
based
done.
on, sorry,
based on which the alert is going to be sent.
yes
Comparing.
yes based on those thresholds. So once the threshold is compared, then we are sending the data to Telegram to like we need to have a plugin like NodeRED contrib Telegram chat, and you can see the node is this Telegram sender. So I think, sorry, this is the one sender. So it can send data in message.payload. So but to send it in to Telegram, you need to format the data like this. In object payload type, you need to define it as a message, and in object payload chat ID, you need to put the chat ID to whom you are going to send. This is my chat ID, and this is the group that I have created, including all of you. And like if there is no content, then I am not sending any message. So now it sends the message, and this is a debug, like it literally prints everything in the right side panel. And also there is another node, show alert dialog. I will show you this thing in a moment. Now coming to the last flow, this is a alert switch, like we may want to turn on or not turn off the alerts. So this is a switch, so this is a dashboard. So there are many dashboard functions you will see. So this is a dashboard switch. So we can create user interface with NodeRED. Now if I open the user interface, you can see this is our dashboard. So we have this enable alerts here. So this is basically the enable alerts thing. You can see we have assigned it to a group, sensor config. So in our layout we have created a smart agriculture group. In that group we have this smart configuration, and here you can see this enable alerts. This is our group, this is our layout, and this is our button switch. But there is another thing. This you have looked here, the whole UI. So this UI is coming from this template. You can see you can also write your own HTML JavaScript code. So by using this template. So we used this template. Here we have defined a UI, so that we can take input of a form. The form is basically the humidity, temperature, light intensity, soil moisture, and livestock, the minimum maximum threshold. So if I save this configuration and if I enable the alerts, so now if I go to the debug window, let me clear all these things. Okay, I have not talked about this show alert dialog. So we are sending the alert to the bot. So I thought, why not we don't we show the alert in the UI as well? So this is the UI that we are using. So you can see there is also a alert being shown in this UI. So this is basically coming from this node. And if you look at Telegram now, so see, and there is 100 message. It just given me the same alert in Telegram as well. So yeah, that's basically what we have done here. And you can look, if you are interested, you can look at the code of this compare threshold or the Java one. I will submit those things in GitHub then. And we haven't used any SQL database. We haven't used any adminer or co-app.
We will remove it.
Yeah, from the reports. So we basically used MQTT, Influx, Telegram bot. Then we used NodeRED for templating to create the UI, and we have shown the we have created some switches to enable or disable. Maybe we can show the professor by changing some settings, like the chicken's heartbeat is 199. Let's make it 200 minimum and maximum. Oops. So now if something is more than 200, it will also give alerts instead of 299. So it runs every 5 seconds and then looks for, like, if there is any kind of situation to create an alert or not. So you can see livestock heartbeat is 266. Previously it was 299, the threshold. Now even at 266 it's giving some alerts. You can come here and see it's giving an alert. So I can turn off the alerts. So now the alerts are stopped. You can save the configuration, and now so you can see the enable alerts are off, so you won't receive any Telegram alerts anymore. Yeah, so that's it.